So in the previous module, we dealt with creating vector data. And what we're going to work with now is creating tabular data, or working between different layers of tabular data so that we can associate things together in a more effective way. So just to review real slightly, the tabular data that we have in attribute data, or attribute tables, are not exactly like a conventional spreadsheet. We can't have multiple types of data within the same column. We're limited to one type of data in each field, but we can relate different tables together in a few systematic ways. So these attribute tables are fundamental to the strength of a GIS system, and we can look at them as part of this larger spatial database and then tie them together either based on spatial location between two features or two tables that have spatial data with them, or we can tie them to other non-spatial data based on a common field. So the way that we have these stored in ArcGIS is what's called a DBF format, and this is an old database file format. It's a full database. We can have fields with one type. We can use we use them for the attribute tables, but they can also be standalone tables within a geodatabase or within our data that we're working with. Now I mentioned that this was an older file format, and from that comes kind of a not insignificant problem, and that is that the DBF file format is an older one, and because of that, Microsoft Excel has removed the ability to read and write these files without having some plugins installed. Workarounds to this are to use either OpenOffice or LibreOffice or one of the other open source spreadsheet programs. Or the fact that the newer versions of ArcGIS can read Excel files also. They're just not as good at it because there can be some different formatting types. There can be some different things that happen in Excel files that are sort of restricted from happening in the DBF files. So we have a number of different types of fields that we can use. As we've already talked about, we can have numeric, so we can have our floats, our integers, our doubles. We can have text, we can have dates. There's some other types of fields that we can have in what are called geodatabases, so a different way, something other than shapefiles that we can use to store vector data. And in these cases, we can have pictures, we can have links, we can have sort of true-false variables in there as well. We're not going to directly use these in the demonstrations, but I want you to at least be aware that they exist. So an important thing to think about when we're creating these data tables and when we're beginning to do these types of analysis in ArcGIS is how we have the data organized. And as an example of this, I have up here the locations of a certain number of trees that have spatial locations, and then how many of 5 different species of birds have been observed at each one of these trees. So there are different ways we could organize the data that we have here. The way that we might think about doing it is what we call a horizontal method, where we have each tree as the records, as the individual rows, and then the number of each species of bird that were found, that were observed there as columns. So bird A has a column, bird B has a column. But we could do it another way as well. We could have it so that for each bird, we had how many times it had been observed at each one of the trees. So we could have the A column, the birds be the horizontal column, be the records, and then the trees be the fields as well. We would call this a vertical organization. Now, when we're dealing with this in a GIS context, it's better to use the horizontal method because what we want to have is the location, the spatial location, the thing that can be tied to a spatial location, to a point, a line, or polygon, be the record itself. So we want to use the trees this way. There are ways to go back and forth. We can pivot table, we can do all sorts of things. We might need to use another program to do those. So it's better to just start off having them in the system that you want them to be. So always think about it so that your locational data is what's in the records itself. Now let's look a little bit about how we have different types of relationships between tables, because there's 2 different ones that we're going to experiment with in the demonstration for this week. The first of which is what we call a one-to-one relationship, where we're going to tie one table to another based on an index field between them. So what we see here is we have IDs up So we might have the IDs of all of those trees that are part of the attribute table for a shapefile. And then we might have a separate table that's what birds were seen at each one of those trees. So we didn't record spatial data, we just recorded which tree we were at, but we have the spatial data for that tree, and we want to link these two tables together. So in this case, we have what we call a one-to-one relationship. There's a single record for each tree in each table. So there's tree 1 in one table, tree 1 in the other table, tree 2 in one table, tree 2 in the other table. It's not necessary for every record to have a value, but there can only be one in each table. We can't have two tree 2s in there, in either one. And this is a good way we can use this to keep kind of our spatial data small and compact, and then just simply join on, create that one-to-one relationship whenever we want to query back and forth between them. Now the contrast to this, a more complicated version of it, is what we call a one-to-many relationship. Where we might have our spatial locations, our trees, but then we might have multiple different records for each tree. So if, say, we had time in there as well. So we had the number of birds seen in January at tree 1 and the number of birds seen in February at tree 1. We can't do a one-to-one relationship because there's multiple tree 1s in that second table. But what we can do is create a one-to-many relationship where we can query back and forth between them. So say query to show all of the records from tree 1 or show all of the records of the trees where all the records from January happened. So it's important when we're dealing with either one of these relationships in ArcGIS to think about it that the spatial information, the points, lines, and polygons, are going to be the starting point. So its attribute table is probably going to be the first table that you're working with. And then if we create a one-to-one relationship, a join between that table and something else, another unassociated data table, it'll actually add all of that information into the attribute table for our shapefile. So we'll get everything in there together, and we'll be able to query it, symbolize, do anything that we might want to do within that one shapefile. If we do a relate, so that one-to-many relationship, it's going to allow us to do querying and selecting back and forth between the tables, but nothing's going to be manually added into one, nothing's going to be physically added into one attribute table or the other. So to run these joins, to run a join in ArcGIS, is essentially going to use this one-to-one relationship to append everything into the attribute table. It can be really useful if we want to have multiple sets of information that we associate with one spatial layer, whether it be parcels, trees, or something like that. But we don't want to have this giant attribute table. This way we can sort of do it on the fly. So here's an example of this. We have counties. We have a shapefile representing counties. And for each county, we have the ID number of it, something called the FIPS code. It's an index, it's an ID for that county, but it's just a numerical one. And then we have a separate table that for each FIPS code tells us the name of it. If we want to get it so that we have the actual name and any other data that is in that table in our original attribute table, this is where we do a join. So we simply find the index field, the county FIPS, between the two, and we use that to sort of join them together. And what will happen is it'll add all of those new records, those records from the second table, into the attribute table for the first one. Now, doing a relate is a relatively similar process. It just doesn't append any data into the attribute table for the shapefile. So instead, it'll allow us to do these sort of selections back and forth. So we'd run it the same way. We'd use the index field, define the index field between the two. And what will happen in this case, we have for each one of these counties, we have a whole lot of different township population records, so demographic data for each township. And we want to relate these together, but we can't add them in because it's a one-to-many relationship. So once we've run the relation by defining the index field and getting it all processed, we now have the ability to query back and forth. So we could select a particular county and then see all the records for that county. Or we could select places that have one of their townships with, say, a higher population than any other, and see what counties those were found in. Now, something else that we can do with these tables and databases is we can calculate new fields. So just like we would in a spreadsheet, we can make an equation to calculate a new field that was, say, total population if all we had was population of different ethnic groups. We can even do this with multiple tables putting together as long as they're joined. As long as we have those tables joined, we could use one table, data from one table and one table, data from multiple different tables to create one new field. Now, something else we can do is what's called creating summary tables, where we're essentially going to go through and summarize all of the values within a table based on one particular field. So if we had all of those county data in place, we had a bunch of different townships within those counties, we could calculate the average or total population for each county. So we could summarize all of the records, all 5,000 or so records, based on the 10 values that exist in that one field. And what this can be really, really useful for is taking what was previously a one-to-many relationship and creating a summary one-to-one relationship out of it, so we can do a join. So let's see an example of this. So if we have the table of census data that has these townships with multiple entries for each county, nothing spatial, but we want to associate it with the counties. We can create a summary table based on the FIPS code. So we go through and we find out the mean and the average population and the total population for each one of those FIPS codes. We have a new table now that just has a limited number. It has the counties, has the FIPS code for the county, and then the population demographic average in there, total and average. Then we can join that back onto the original shapefile that now we have the average, the total population for that county based on all of the township data that we had. So because of this, we've gone through and we've created a summary one-to-one relationship out of something that was previously a one-to-many relationship. Now, before I conclude, I want to just mention the concept of geodatabases as well. And geodatabases are an alternate form of storing both vector and raster data that ArcGIS has in place. There are a couple different types of them. They all work largely functionally the same. And essentially what it is it's one file where all of your different layers are stored. That has advantages and disadvantages. Historically, they tended to be used in big business applications where many people are working on the same GIS data over a network. But they're really getting promoted quite heavily for daily use and kind of in research tasks as well. So some of the key advantages are, well, first off, this is where most of the development is happening. So new tools tend to be more associated with geodatabases than they are with shapefiles. So it may be the future of GIS computing. One of the other big advantages is everything is stored in the same location. So it's really easy to make a backup of your data. You just have to copy one file. All the data, by their nature, are sort of set to the same spatial projection, so you don't have to deal with reprojecting things more than once. You can set up permanent joins and relates, permanent relationships between different tables. There's some advanced editing and rules and advanced types of files you can have in there, and geometry types as well. You can have pictures associated. You can do some different types of temporal data as well. But there are a couple of disadvantages. First off, it's often sort of overkill for the average GIS user. There are some permission errors that happen occasionally. And even more important, and the main reason why I don't teach them in these modules, is that if that one database file comes corrupted, or you accidentally lose it, or you delete something by accident, you're going to lose all your data. So I find it better in this context when we're doing instruction on GIS to keep them as separate files, separate shape files and separate layers. So that's what we're going to be working with, but I want you to at least be aware that these exist, that there is a possibility of working with these geodatabases. And in the future of your GIS career, it may be something that you want to explore. So that's a good overview of tables and databases, different types of relationships, how to query back and forth between things. In the next module, we're going to get even a little bit more complicated and start looking at some of the basic ways that we can do temporal data.